In this video, we're going to take a quick look at integrating products of sines and cosines of different angles. So in this particular case, we have formulas. So in the last video, we were learning techniques. Technique means, okay, you look at the sine, the cosine, you see, do they have even powers, do they have odd powers, and you develop a procedure. In this case, you see that you have, as in this example, you have different powers, different angles rather, different angles. Sine is the angle 5x, cosine is the angle 3 times x. So you're just automatically going to go to these formulas. Now, normally you do not need to memorize these formulas. You will have these formulas available to you. And it's just a matter of picking out the correct formula and kind of plugging in appropriately. So just going to do one example here real quick, or maybe two. So in this particular case, we have sine and cosine. So that's what you want to look at. You have sine and cosine. You have the sine function. I'm using brown. It's kind of an ugly color. I'm going to go back to something a little more prettier. Let's go there. So you have a sine function and a cosine function. So let's see, it would be this one right here, sine and cosine. The first one is a sine, sine. Third one is cosine, cosine. The middle one is sine, cosine. And so A is going to be 5. The B is going to be 3 in the formula. So the formula says you take 1/2 the sine of A minus BX. So 5 minus 3 is 2. So we have 1/2 sine of 2x plus 1/2 sine of A plus B. All right. And so we end up with, I think I was supposed to have a plus sign there, wasn't I? Yeah, plus 1/2 the sine of 5 plus 3 is 8x. And then we are going to integrate it. All right, from there, we integrate it. So we change it into some form that we can find the antiderivative of. So again, the antiderivative sine of 2x is going to be 1/2 cosine of 2x times the 1/2 is negative 1/4. The antiderivative of sine of 8x is 1/8 cosine of 8x, and the 1/8 times the 1/2 is the 1/16. So there we go. So basically use the appropriate formula to get you to someplace where you can integrate it. The next one is I changed this one. So if you're wondering, in your version of the notes it says sine cosine. I know, I apologize. I figured I already had one of those. So in my video, I changed it to cosine 4x, cosine 7x, even though I did not change it in the original set of notes. So you can do it both ways. Try doing it both ways. But I'm doing it cosine of 4x, cosine of 7x. That way, we can go back and say, okay, cosine, cosine, that's going to be this one right here. And so we want 1/2 the cosine of the difference between the angles plus 1/2 the cosine of the sum of different angles times x. So plugging that into the formula, we end up with this. And the other thing is, you might be wondering, like, when you follow the formula and you do the A minus B, all right, the A minus B, well, if you do A is 4, and B is 7, you're going to end up with a negative 3. You're going to end up with a negative angle. But there's no reason why you can't just switch those two around. In other words, cosine of 4x, cosine of 7x is the same as cosine of 7x, cosine of 4x. Commutative property of multiplication. All right, so I just switched the order, so I got a positive angle rather than a negative angle. You would have just had to use some negative angle identities to switch it around. You'd have gotten to the same place, but this is a little bit easier. All right, so once you use the formula to get it to this point, it's the matter of integrating it. So the antiderivative cosine is sine times a 1/3 times the 1/2 is a 1/6. And here you can have a 1/11 times 1/2 is 1/22 sine of 11x. Boom, done. All right, now I'm going to skip ahead to the end of my notes. I'm going to skip over the integrating products of powers of tangent secants for its own separate video. Let's go to the reduction formulas. So the reduction formulas, again, these are just formulas. Plug and chug, okay? Plug these. You don't need to memorize these. You can have them written down somewhere, and you can use them. So this is what you use if you have the integral of secant to some power n, or tangent to some power n. You can use the reduction formulas. Sometimes you can do them by using other techniques, but the reduction formulas will help you to solve these. They just give you a formula to follow. So with exercise number 14, we have the tangent to the fourth. Right, so the tangent to the fourth, we're going to use the tangent formula. It says we do 1 over n minus 1. Well, n is the power. The power is 4. So 1 over 4 minus 1 is 1/3. And then it is tangent to the n minus 1 power, so that would be the third power. So 1/3 tangent cubed. Minus the integral of tangent to the n minus 2. So that's going to be minus the integral of tangent squared. Well, we've got to use it again. We've got a tangent squared. Let's go back and use this formula again. So, being very careful, putting it in brackets. So we want 1 over n minus 1. So that would be 1 over 2 minus 1 is 1. So we just get tangent of x minus the integral of the tangent to the n minus 2. Well, n minus 2 is 2 minus 2, which is 0. So you get tangent to the 0 power, which is 1. So we just have 1 dx. All right, then distributing through this minus, okay, we're distributing through that minus and removing the brackets. We end up with this. And then it is just a matter of integrating. Oh, actually, I'm sorry. That was integrated. Right. So we have 1/3 tangent cubed minus tangent of x plus c. There we go. I'm actually not sure if your homework problems have any reduction formula problems, but it's just something I wanted to expose you to in case it comes up. And secant. So with the secant, we're going to go with the first formula, which is very similar. It's 1 over n minus 1 times the secant to the n minus 2 here, times the tangent of x, plus n minus 2 over n minus 1. So it's a little bit different, but same idea. And so using the formula, you simply end up with this. It's just plug it into the formula. Well, actually, you end up with this. Okay, you plug that into the formula, you end up with this. And the integral of secant. Now, the integral of secant is something that you should recall from Calc 1, I believe. And so the integral of secant of x dx is equal to the log of the absolute value of the secant of x plus the tangent of x. And so that's where this comes from. Okie dokie. That is the last one of these. And so this is the end of video 2. Video 3 will be on powers of tangents and secants. See you then.